Audiovisual learning aims to build a multi-sensory perception system that learns from perceived auditory and visual scenes. Mimicking human perception capacity, it can enable a range of downstream tasks, such as sound source localization and video semantic understanding. Although many unsupervised and weakly supervised models have been found useful sometimes, they suffer from low accuracy and high bias on domain-specific tasks. In contrast, supervised learning shows important advantages in model performances and robustness. However, collecting annotated ground truth data is usually a costly and time-consuming process that requires extensive human labor. To address this challenge, we design and develop Peanut, a human-AI collaborative audiovisual annotation tool that makes this process more efficient using several novel mixed-initiative partial automation strategies. Peanut facilitates the data annotation process in two aspects. First, Peanut helps users annotate each frame faster, by identifying candidates of visual objects and audio tags to choose from, reducing human efforts and cognitive loads. Second, Peanut allows user to annotate fewer frames manually by leveraging state-of-the-art single-modal audio and visual models to choose key frames that require human labeling. When annotating individual frames, current tools without AI assistance require users to identify sounding objects and audio tags on their own, manually drawing bounding boxes and typing audio tags. In comparison, Peanut provides intelligent support for annotating both auditory and visual modalities respectively. For the video frame input, Peanut utilizes an state-of-the-art object detector to identify the candidate bounding box for the user to choose, so that users do not need to identify and draw boxes on their own. For the audio clip input, Peanut uses an audio tagging model to predict the tag of sounds contained in the frame. With this model, Peanut can recommend to users a ranked list of sound tags, so that users don't need to struggle with recognizing and naming the sound. Apart from the individual frame annotation support, Peanut only needs human annotations on a few frames by recommending frames to label and populate the labeling to the rest of frames. To do that, we propose a novel algorithm called audiovisual sensitive binary search to do frame recommendation and label population. When users finish the annotation on a particular frame FI, Peanut will recommend users to annotate the next frame FJ that has sharp visual or auditory change relative to the annotated one. At the same time, Peanut will predict the annotation by itself. If the predicted annotation is the same as human annotation on FJ, Peanut will automatically annotate the frames between the FI and FJ through intelligent interpolation. If the prediction is different from human annotation, Peanut will ask users to label the middle frame between FI and FJ. Moreover, if the predicted annotation is the same as the human annotation on FJ but there exists a human annotated frame FK right to FJ, Peanut will apply the same procedure above for the frames between FI and FK. Here is an example when the prediction is different from human annotation on the recommended frame. Peanut also adopts active learning to improve the performance of the object detector and audio tagging model as users annotate more and more frames. Peanut fine-tunes the general off-the-shelf models with a stream of annotations made by users, using few-shot learning to increase models' accuracy on specific domains. To mitigate the over-reliance issue, Peanut has two features to assist users review the annotation results so that users can identify the annotation mistakes and calibrate their trust in the system. The frame-by-frame thumbnail feature allows users to easily skim the annotation status of each frame. In contrast, the annotated video preview feature allows users to know how the entire video after annotation looks like, so that users can have a global-level assessment of annotation quality.